So for this first example, we're going to demonstrate the notion of fair sharing. And this problem says, three friends, Mo, Larry, and Curly, are dividing up a set of assets S into three shares. The shares are labeled S sub 1, S sub 2, and S sub 3. And that's how that's pronounced. We have these little subscripts of a 1, 2, and a 3. That's how we tell one share from another. The table shows how each friend values the individual shares. Determine a fair division of the assets S for the friends. Now, a fair share is the least proportional amount that a player expects to receive from a set of assets. So the way that's determined is if we have the number of players, and we could just label the number of players as N, then the least proportional amount that a player expects to receive would be 1 over N. That's a proportion. And since we have three friends here, Mo, Larry, and Curly, for this particular problem, that's three players. So then each player expects to get at least 1/3 of the assets. Or we can write that as 33 1/3%. If there were two players, then each player would expect to get 1/2 or 50%. If there were four players, then each player would expect to get 1/4 or 25%. And so on. But for this particular problem, there's three players. Each player expects to get, and this is at least 33 1/3%. So as we look at the table here, we can see that each player, though, values the shares differently than anyone else. We can see here that Mo values the first share at 30% of the overall assets here. He values the second share at 38% and the third share at 32%. If we were to add up all these percentages, they have to equal to 100% because then all the shares are accounted for. That's the entire set of assets. Larry, he values the shares differently than Mo. 34% for the first share, 35% for the second share, and of course 31% for the third share. Again, if we were to add up all these shares, that's 100% of the shares, or that's the entire set of assets. And Curly here, he just happens to value each share equally. Nonetheless, go ahead and add them all up, and that should also be 100%. That's one way of being able to check that your values are distributed according to how each individual sees them. Now what we need to do is now divide these shares. Who gets which share? Well, if you look at Curly down here, it doesn't really matter which share Curly gets because no matter which share he's awarded, he's always going to get at least 33 1/3% or 1 over N or 1/3 of the assets. Mo up here, the only share that he values at least 33 1/3% is the second share here. So we have no other option but to make sure that Mo gets that share. So he's going to be awarded the second share. We wouldn't award him the first or the third share because that's less than the 33 1/3 that he's expected to get. Larry, he likes the first share. He's got that at least 33 1/3% and the second share. However, the second share was already awarded to Mo. So then the first share has got to go to Larry. He wouldn't get the third share because that's not at least 33 1/3. So he winds up getting the first share. And it doesn't really matter which shares Mo and Larry get. It doesn't really matter to Curly because Curly values each one of them equally. But the only one left is the third share. So a fair division of this set of assets would mean that Mo would get share 2. Larry would get share 1. And Curly is then awarded share 3. And it's a fair division because each player got at least the proportional amount that they think is due to them. Now, if we look at Larry here, notice that Larry values share 2 more than the first share. So fair division doesn't guarantee that you'll get your best or your favorite share. It only guarantees that you'll get at least the proportional amount, which is 1 over n, or 1/3. And there we go.